After studying this module, you will be able to understand the notion of asymmetry in information, learn about the different outcomes of asymmetric information, analyze the problem of adverse selection in various markets, and identify the various market responses in the form of signaling and screening to cope with the problem of adverse selection. Asymmetric information. Till now, it has been assumed that consumers and producers have complete information about the economic variables that are relevant for the choices they face. In this module, we will examine a situation where the characteristic of perfect information does not exist. In such a case, some parties may have more information about the transaction than others. This is a situation of asymmetric information. The asymmetry in information can arise from two types of information. First, about the characteristic, wherein one side knows some characteristic which the other side would like to know, and second, about an action that one side can take and the other side cannot directly observe. The former is referred to as a situation of hidden characteristic, and the latter is referred to as a situation of hidden action. In such situations, the markets perform differently, leading to inefficiency and undesirable outcomes. The present module focuses on hidden characteristics, and the subsequent module discusses hidden action. Hidden characteristic, adverse selection. One of the outcomes of asymmetric information is adverse selection. Adverse selection is a hidden characteristic problem. It refers to the situations where one side of the market is unable in observing the type or quality of the goods that the other type of market is using. In other words, the seller knows more about the attributes of the good being sold than the buyer does. In such a situation, the buyer runs the risk of being sold a good of low quality. That is, the selection of goods sold may be adverse from the standpoint of the uninformed buyer. The classic example of adverse selection is the market for used cars. Sellers of used cars know their vehicles' defects while buyers often do not. The owners of the worst cars are more likely to offer them at a price higher than their actual marginal cost because of the advantageous information asymmetry. Another example of adverse selection occurs in the labor market. The workers who vary in their abilities may know their own abilities better than do the firms that hire them. When a firm cuts the wage it pays, the more talented workers are more likely to quit, knowing they are better able to find other employment. Market for lemons. Now let us look at the standard example of a market for second-hand used cars to illustrate the implications of the problem of adverse selection. Consider a market with 100 people who want to sell their used cars and 100 people who want to buy a used car. Everyone knows that 50 of the cars are good cars and 50 are lemons, that is bad cars. The quality of each car is known to the current owner, but the prospective purchasers have no idea whether any given car is a good car or a lemon. The owner of a lemon is willing to give it for rupees 60,000 and the owner of a good car is willing to give it up for rupees 1,50,000. The buyers of the car are willing to pay rupees 2 lakh for a good car and rupees 90,000 for a lemon. If it is easy to verify the quality of the cars, there will be no problem in this market. The lemons will sell at some price between rupees 60,000 and rupees 90,000, and the good cars will sell at some price between rupees 1,50,000 and rupees 2 lakhs. But if the buyers are unable to observe the quality of the car, then in that case the worth of the car will be guessed by the buyer. Let us assume that if a car is equally likely to be a good car as a lemon, then a typical buyer would be willing to buy the expected value of the car. Using the numbers described above, this means that the buyer would be willing to pay half of 90,000 plus half of 2 lakhs, which is equal to rupees 1,45,000. At this price, the owners of the lemons would certainly be willing to sell their car, but the owners of the good cars wouldn't be willing to sell their cars. By assumption, they need at least 1,50,000 rupees to part with their cars. The price that the buyers are willing to pay for an average car is less than the price that the sellers of the good cars want in order to part with their cars. At a price of rupees 1,45,000, only lemons would be offered for sale. But if the buyer was certain that he would get a lemon, then he would not be willing to pay rupees 1,45,000 for it. In fact, the equilibrium price in this market would be somewhere between rupees 60,000 and rupees 90,000. For a price in this range, only owners of lemons would offer their cars for sale, and the buyers would therefore correctly expect to get a lemon. In this market, none of the good cars ever get sold, even though the price at which the buyers are willing to buy good cars exceeds the price at which sellers are willing to sell them. No such transactions will take place. It is worth contemplating the source of this market failure. The problem is that there is an externality between the sellers of good cars and bad cars. When an individual decides to try to sell a bad car, he affects the purchaser's perceptions of the quality of the average car in the market. This lowers the price that they are willing to pay for the average car, and thus hurts the people who are trying to sell good cars. It is this externality that creates market failure. The cars that are more likely to be offered for sales are the ones that people want most to get rid of. The very act of offering to sell something sends a signal to the prospective buyer about its quality. If too many low quality items are offered for sale, it makes it difficult for the owners of high quality items to sell their products. Quality choice. In the lemons model, there was a fixed number of cars of each quality. Now let us consider a variation on that model where quality may be determined by the producer. We will show how the equilibrium quality is determined in this simple market. Suppose that each consumer wants to buy a single umbrella and that there are two different qualities available. Consumers value high quality umbrellas at rupees 240 and low quality umbrellas at rupees 100. It is impossible to tell the quality of umbrellas in the store. This can only be determined after a few rainstorms. Now suppose that some manufacturers produce high quality umbrellas and some produce low quality umbrellas. Now suppose further that both high quality and low quality umbrellas cost rupees 180 to manufacture and that the industry is perfectly competitive. In such a situation, what would be the equilibrium quality of umbrellas produced? Now suppose that consumers judge the quality of the umbrellas available in the market by the average quality sold, just as in the case of the lemons market. If the fraction of high quality umbrellas is Q, then the consumer would be willing to pay P equal to 240Q plus 100 into 1 minus Q for an umbrella. There are three cases to consider here. First, only low quality manufacturers produce. In this case, then the consumers would be willing to pay only rupees 100 for an average umbrella. But it costs rupees 180 to produce an umbrella, so none would be sold. The second case is where only high quality manufacturers produce. In that case, the producers would compete the price of an umbrella down to marginal cost, that is rupees 180. The consumers are willing to pay rupees 240 for an umbrella, so they would get some consumer surplus in this case. Third case is where both qualities are produced. In that case, competition ensures that the price will be rupees 180. The average quality available must therefore have a value to the consumer of at least rupees 180. This means that we must have 240Q plus 100 into 1 minus Q greater than or equal to 180. The lowest value of Q that satisfies this inequality is 4 by 7. This means that if 4 by 7 of the suppliers are high quality, the consumers are just willing to pay rupees 180 for an umbrella. The determination of the equilibrium ratio of high quality producers is depicted in figure 3.1. The horizontal axis measures Q, the fraction of high quality producers, and the vertical axis measures the consumer's willingness to pay for an umbrella if the fraction of high quality umbrellas offered is Q. Producers are willing to supply either quality of umbrella at a price of rupees 180. So the supply conditions are summarized by the bold colored horizontal line at rupees 180. The slanted line represents the demand conditions. Consumers are willing to pay more if the average quality is higher. Consumers are willing to purchase umbrellas only if 250Q plus 100 into 1 minus Q is greater than or equal to 180. The boundary of this region is illustrated by the dashed line in the figure. The equilibrium value of Q is between 4 by 7 and 1. In this market, the equilibrium price is rupees 180, but the value of the average umbrella to a consumer can be anywhere between rupees 180 and rupees 240 depending on the fraction of high quality producers. Any value of Q between 1 and 4 by 7 is equilibrium. However, all of these equilibria are not equivalent from the social point of view. The producers get zero producer surpluses in all the equilibria due to the assumption of pure competition and constant marginal cost. Here it is easy to see that the higher the average quality, the better off the consumer is. The best equilibrium from the viewpoint of the consumer is the one in which only the high quality goods are produced. Now let us change the model a bit. Suppose that each producer can choose the quality of umbrella that he produces and that it costs rupees 180 to produce a high quality umbrella and rupees 170 to produce a low quality umbrella. Suppose that the fraction of producers who choose high quality umbrellas is Q, where Q lies between 0 and 1. Now consider one of these producers. If it behaves competitively and believes that it has only a negligible effect on the market price and quality, then it would always want to produce only low quality umbrellas. Since this producer is by assumption only a small part of the market, it neglects its influence on the market price and therefore chooses to produce the most profitable product. But every producer will reason the same way and only low quality umbrellas will be produced. But consumers are only willing to pay rupees 100 for low quality umbrella. So there is no equilibrium in this case, or the only equilibrium involves zero production of either quality of umbrella. The possibility of low quality production has destroyed the market for both qualities of the good. Market responses to adverse selection. From the above discussion, it is evident that asymmetric information can sometimes lead to a lemon problem. Because sellers know more about the quality of a good than buyers do, buyer may assume that the quality is low, causing prices to fall and only low quality goods being sold in the market. Markets respond to the problems of asymmetric information in many ways. One of them is signaling, which refer to activities taken by an informed party for the sole purpose of credibly revealing his private information. The other is screening, wherein an uninformed party takes actions to induce the informed party to reveal private information. Market signaling. In the case of market for lemons, the owners of the good cars have an incentive to try to convey the fact that they have a good car to the potential buyer. But they would like to choose actions that signal the quality of their car to those who might buy it. One sensible signal in this context would be for the owner of a good used car to offer a warranty. This would be a promise to pay the purchaser some agreed upon amount if the car turned out to be a lemon. Owners of the good used cars can afford to offer such a warranty, while the owners of the lemons cannot afford this. This is a way for the owners of the good used cars to signal that they have good cars. In this case, signaling helps to make the market perform better. By offering warranty, that is the signal, the sellers of the good cars can distinguish themselves from the sellers of the bad used cars. Now let us consider a simple model of the education market to examine how signaling works. Suppose that we have two types of workers, able and unable, in a competitive market. The able workers have a marginal product of A2 and the unable workers have a marginal product of A1, where A1 is less than A2. Suppose that a fraction B of the workers are able and 1 minus B of them are unable. For simplicity, we assume a linear production function so that the total output produced by L2 able workers and L1 unable workers is A1 L1 plus A2 L2. If the worker quality is easily observable, then firms would just offer a wage of W2 equal to A2 to the able workers and of W1 equal to A1 to the unable workers. That is, each worker would be paid according to their marginal product and there would be an efficient equilibrium. But if a firm cannot observe the marginal products and distinguish the types of workers, then the best that it can do is to offer the average wage, which is W equal to 1 minus B A1 plus B into A2. As long as the good and the bad workers both agree to work at this wage, then there is no problem with adverse selection. And given the assumption about the production function, the firm produces just as much output and makes just as much profit as it would if it could perfectly observe the type of the worker. However, suppose that there is some signal that the workers can acquire that will distinguish the two types. For example, suppose that the workers can acquire education. Let E1 be the amount of education attained by type 1 workers and E2 the amount attained by type 2 workers. Suppose that the workers have different costs of acquiring education, so that the total cost of education for the able workers is C2E2 and the total cost of education for the unable workers is E1C1. These costs are meant to include not only the rupee cost of attending school, but also the opportunity cost, the cost of the effort required, and so on. Now there are two decisions to consider. The workers have to decide how much education to acquire, and the firms have to decide how much to pay workers with different amounts of education. Let us make the extreme assumption that the education doesn't affect worker productivity at all. It turns out that the nature of the equilibrium in this model depends crucially on the cost of acquiring education. Suppose that C2 is less than C1. This says that the marginal cost of acquiring education is less for the able workers than for the unable workers. Let E star be an education level that satisfies the following inequalities, that is A2 minus A1 by C1 is less than E star, which is less than A2 minus A1 by C2. Given the assumption that A2 is greater than A1 and C2 is less than C1, there must be such an E star. Now consider the following set of choices. The able workers all acquire education level E star and the unable workers all acquire education level 0. And the firm pays workers with education level E star a wage of A2 and workers with less education than this a wage of A1. Note that the choice of education level of a worker perfectly signals his type. Now the question is whether the workers are behaving rationally given the wage schedule they face. Would it be in the interest of an unable worker to purchase education level E star? The benefit to the worker would be the increase in wages A2 minus A1, and the cost to the unable worker would be C1 E star. The benefits are less than the cost if A2 minus A1 is less than C1 E star. But this condition holds by the choice of E star. Hence, this implies that the unable workers find it optimal to choose a 0 educational level. Now the question arises, is it actually in the interest of the able workers to acquire the level of education E star? The condition for the benefits to exceed the cost is A2 minus A1 should be greater than C2 E star. And this condition also holds due to the choice of E star. Hence, this pattern of wages is indeed equilibrium. If each able worker chooses education level E star and each unable worker chooses a 0 educational level, then no worker would have any reason to change his behavior. Due to this assumption about the cost differences, the education level of a worker can in equilibrium serve as a signal of the different productivities. However, this equilibrium is inefficient from the social point of view. Each able worker finds it in his interest to pay for acquiring the signal, even though it doesn't change his productivity at all. The able workers want to acquire the signal not because it makes them any more productive, but just because it distinguishes them from unable workers. Exactly the same amount of output is produced in the signaling equilibrium as would be if there was no signaling at all. In this model, the acquisition of the signal is a total waste from the social point of view. This inefficiency arises because of an externality. If both able and unable workers were paid their average product, the wage of the able workers would be depressed because of the presence of the unable workers. Thus, they would have an incentive to invest in signals that will distinguish them from less able. This investment offers a private benefit but no social benefit. Signaling doesn't always lead to inefficiencies. Some types of signals, such as the used car warranties described earlier, help to facilitate trade. In that case, the equilibrium with signals is preferred to the equilibrium without signals. So, signaling can make things better or worse. Each case has to be examined on its own merits. Screening. When an uninformed party takes an action to induce the informed party to reveal private information, the phenomenon is called screening. A person buying a used car may ask that it be checked by an auto mechanic before the sale. A seller who refuses this request reveals his private information that the car is a lemon. The buyer may decide to offer a lower price or to look for another car. In the insurance market, insurance companies have come up with a good number of screening devices. One of the most commonly used screening mechanisms is the medical examination, which screens an individual and categorizes him as healthy or sick. While such an examination prevents adverse selection, which is desirable from the company's point of view, socially the test does not add value. If anything, it imposes a cost on the individuals and deprives a section of the society of the benefits of insurance, because insurance policies are priced very steeply for sick individuals. Summary. Now let us summarize the above discussion. A. In many economic transactions, information is asymmetric, that is, a situation where some people are better informed than others. B. Asymmetric information causes significant problems with the efficient functioning of a market. C. The asymmetry in information can arise from hidden characteristics wherein one side knows more characteristics which the other side would like to know but does not. D. Hidden characteristics lead to situations where the types of agents is not observable, so that one side of the market has to guess the type or quality of the product based on the behavior of the other side of the market. This leads to the problem of adverse selection. E. In markets involving adverse selection, too little trade may take place. A buyer of a car gets to trade with sellers of bad cars only. A health insurance company gets to trade with only unwell people. F. In situations of adverse selection, the informed party looks for indicators of hidden characteristics called signals and often use a screening device to sort out customers according to their willingness to pay.